Hello viewers on YouTube. Now let's solve the problem we have before us right on board. So try to pause the video and take a deep breath and think of the first step you can take in order to simplify this problem. So let's begin by modifying the equation first. For the left hand side, let's express x raised power y as x raised power y divided by 2 all to the power of 2. Then for y to the power of x, let's do the same thing and have it as y to the power of x over 2 all to the power of 2 to be equal to 17. This makes sense because by the time we expand the bracket, the parentheses back, then we should end up with this. Now, let's try to make some other new substitution. So let's x to the power of y over 2 be equal to new variable a and y to the power of x over 2 to be equal to new variable b. And this clearly implies that we now have a to the power of 2 minus b to the power of 2 to be equal to 17. Now in algebra, we learned that when we have the difference of two squares, then it becomes simplified and we express as a minus b multiplied by a plus b, and this is equal to 17. So right now, we want to express 17 as a product of two numbers. Well, since 17 is odd number, then it can only be expressed as 17 times 1. 17 is prime to say in excess, because if it is odd, then there should be something else that can actually reduce it other than itself and 1. But it's prime, so it can only be reduced by 1 and itself. Now at this point, we can set a minus b to be equal to 17 and set a plus b to be equal to 1 and see if we can sort things out. Upon doing that, we have a minus b to be equal to 17. Then we continue that as equation 1 and then a plus b to be equal to 1 and have that to be equation 2. Now clearly we now have two linear equations which you can solve simultaneously. So let's add the two equations. A plus a is simply 2a, and negative b plus b will cancel out, and this will now be equal to 17 plus 1. That's simply 18. So now we have 2a to be equal to 18. Now upon dividing through by 2, we would observe that at the end of the day we have the value of a to be equal to 9. So that is the value of a. Now that we have the value of a, let's plug it right into equation 1 to get the value of b. Well, you can do the same thing for equation 2 by just substituting the value of a to get b. You should end up with the same result. So in equation 1, we have a minus b to be equal to 17. This clearly means that the value of b would be equal to a minus 17. Am I communicating? That's a minus 17. Now, a is 9, then it means b will be equal to 9 minus 17, and we have b to be equal to minus 8. That's excellent. Now, if we use equation 2, in equation 2 we have a plus b to be equal to 1. A is 9, we are aiming to solve for b. Then upon subtracting 9 from both sides, we have b to be equal to 1 minus 9, which is minus 8. That's perfect enough. So that's the value of b. Now that we have a and b respectively, we can try to recall our substitution we made right from the start. Since a is equal to x to the power of y over 2 and b is equal to y to the power of x over 2, then we can replace as follows. as what we have right here. So thus we now have, let me have that in yellow now. We now have x to the power of y over 2 to be equal to 9, and y to the power of x over 2 to be equal to minus 8. So basically at this point, we can square both sides to get rid of the halves. So by squaring both sides, we have x to the power of y over 2 all squared to be equal to 9 squared. And then we have y to the power of x over 2 all squared to be equal to minus 8 all squared. So this can cancel out, and left over is x to the power y equals to 9 squared is 81. And then we have these two also cancels out, and we have y to the power of x to be equal to minus 8 squared is 64. Perfect. So basically now, what we have here is a little bit similar to what we have here. The only difference is change in the position of the variable. So we can try to see if we're going to express this as an index. It's obvious that 81 is the same thing as 3 to the power of 4. So if we have x to the power y to be expressed as, to be equal to 3 to the power of 4, and then we have y to the power x to be equal to 1. Well, absolutely 64 is the same as 4 to the power of 3. Now clearly, by judging what we are seeing, if we set x is equal to 3, then it means we are saying that y is equal to 4. Now if this is going to be 3, then if we plug in the corresponding value here, we must get this, which we actually did. So thus, we can clearly say that the value of x is equal to 3 and the value of y is equal to 4. And that gives us a solution to satisfy the given equation. Now, another way you can see this problem is to inspect. You can consider substituting some random values until you get a value that satisfies the equation. Now this is what I want you to know. This problem is a single equation itself, but unfortunately it consists of two different variables. However, for we to have a unique solution for equations that consist of two unknowns, then it's better and it's even perfect if we have two equations. But since we're having one equation now and we are still having two different unknowns, then it means the solution we'll be having might not be unique. What does that mean? It means the 3 and 4 that we have right here might not be the only solution to this problem. We must still have more solutions. The solution can never be unique because this equation is actually a special equation. So what I would suggest is, just in case you come across something like this in the future, just try to satisfy the problem. That is, just get a result that is equal to 17, or that is equal to whatever they say is equal to. But realistically, the equation doesn't have a unique solution. For it to have a unique solution, we must have two equations because it's consisting of two unknowns. So I hope you find this helpful and understandable. So let me know your thoughts, let me know your suggestion in the comment section below. Or do you also think of any other values or solutions that satisfy this problem? Like I said, we might still have more. Yes, because the solutions are not unique. Thanks for watching. See you in the next video. Bye for now.